This is where they are building the largest nuclear fusion reactor in the world. Right now, I am inside the assembly hall of the International Thermonuclear Experimental Reactor in the south of France. And just behind me back there is where scientists and engineers are working to replicate what happens inside the sun. Now, this is so much more than just another energy project. It's a $22 billion science experiment between a whole host of nations all coming together to try and change how we generate power on this planet.
ITER's mission to create a new carbon-free energy source couldn't be more urgent. Global energy use is projected to nearly double by 2050, and we've got to drastically cut our use of fossil fuels. Some scientists hope that controlled nuclear fusion could be the holy grail of energy, but there's a catch. As it stands right now, no reactor has ever been able to produce more energy through nuclear fusion than it takes in. ITER's aiming to be the first, and if it's a success, it could quite literally change the world.
Nuclear fusion, the energy which fires the hydrogen bomb, and the sun. Could this be the pot of gold waiting at the end of the rainbow? To provide energy which is cheap, clean, and inexhaustible.
In November 1985, General Secretary Gorbachev of the Soviet Union made a proposal to US President Ronald Reagan, form an international coalition to develop fusion energy for peaceful purposes. A year later, the EU, Japan, Soviet Union and US all agreed to design a nuclear fusion facility called ITER. Today, that effort's grown to include thousands of engineers and scientists across 35 member nations.
Scientists plan to use this 23,000-ton reactor to, basically in layman's terms, create a tiny star here on Earth that's then used to power the world. Now, if that sounds like a really big deal to you, it's because it is.
The nuclear reactors you're probably familiar with use a process called fission, where atoms are split apart and energy is released in the form of heat and radiation. That's the same process that powers those terrible atomic bombs and the nuclear power plants we have today. It's driven by elements like uranium and plutonium, which can be hard to get hold of and end up as dangerous nuclear waste. Nuclear fusion, however, is the process by which atoms are fused together using elements that are abundant on Earth, like the hydrogen isotopes you can extract from water. Heat generated from nuclear fusion reactors can be used to produce steam that can power turbines and generators to create electricity. Once you can do that, you kind of have an unlimited supply of carbon-free energy that isn't dictated by whether it's sunny or windy. The problem is, achieving efficient, scalable nuclear fusion here on Earth is still really hard to do. You need a machine that can withstand temperatures 10 times hotter than the core of the Sun and twice the force required to launch a space shuttle. That's all to say this thing has to be really, really durable, and that's where the insane levels of concrete and engineering that you see going on here all come into play. Here's how it'll work. Hydrogen atoms are injected into this vacuum vessel, then a giant superconducting magnet around the machine is turned on, and the voltage strips the electrons from their atoms, forming something called plasma. It's a state of matter that's sort of like gas. Hopefully you're still with us. That plasma is then heated to extreme temperatures of up to 150 million degrees Celsius. The atoms then fuse together and release a huge burst of thermal energy in the process. That nuclear reaction produces 4 times as much energy as nuclear fission, and 4 million times the amount of energy you can get from burning the same amount of coal, oil or gas. The ITER tokamak will be the largest and most powerful fusion device in the world, with 1 million components and 10 million parts. Those parts are all made and assembled by ITER's member countries and then shipped here to this 445-acre site in France. It's kind of like building a Lego kit, just 10 million times more complicated.
I'm Colette Ricketts and I work as the Deputy Head of the Project Control Office for ITER organisation. It's my job to make sure that all the bits that are needed to put together the Lego kit that is ITER show up on time, the right colour, the right shape, the right time. I'm the Grand Master of the Lego kit.
With so many heavy components needed to make the machine, 104 kilometres of roadway have been specially modified into something that's now known as the ITER itinerary.
We've built bridges, we've widened roads, we have police convoys to get our components through. It's a massive undertaking just to move a component.
Everything then comes here into the massive assembly hall. Parts are put together and these enormous cranes on the ceiling above my head lifted up and over into the reactor.
At its core, we're still building the same facility we were building and was imagined decades ago. But of course, every week something changes because we're on a global platform. Pandemics, Brexit, political elections. So then we reschedule, we reorientate our programme. I spend most of my time saying, well, that was the plan, but nothing goes to plan, and this is how we're going to adapt.
Now, I'm a self-confessed construction geek, and ITER really is the ultimate construction project. If you thought getting one national government to build an infrastructure scheme was hard, try doing it with 35 nations, all with different languages, cultures and building practices. It's a pretty nuclear level of project collaboration, and tools from Think Projects are helping to make it all happen.
So it's the coming together of these nations who recognise that there's a problem with the environmental conditions, recognise the potential of fusion to solve the baseload energy problem, and are now working together in the most amazing collaborative way. I think there's something like 45 native languages at the ITER head office. It's an amazing thing.
Behind all the concrete, magnets and metal, there's a lot of different people building, shipping and assembling millions of specialised parts. And all those different people contributing to ITER need contracts to get paid and make sure their work is being accounted for. Think Project manages contracts for nearly 400 users across 30 organisations and those 35 nations. It's not the most glamorous part of the project, but it's the glue that kind of keeps the whole thing together. The stakes are high for ITER, and staying organised is essential. There's been a lot of money invested in this, and it's a crucial moment in our energy transition away from fossil fuels and towards renewable sources. The immense project is scheduled to first power on in 2025, when they'll hope to create plasma. Eventually, the goal is to create, at least for a few seconds, what scientists call net energy, where more energy is produced than used. Once that small task is done, the next challenge will be to actually funnel the energy made through fusion into our existing power grids. But that's still a couple of decades away and will likely be taken up by other reactors. ITER isn't the only group trying to harness the power of nuclear fusion. A growing number of coalitions and private companies are racing to figure out how to make fusion power commercially viable and competitive with the price of fossil fuels. The new US infrastructure bill has a number of provisions for nuclear energy research and production. Once someone cracks the code, commercially scalable carbon-free energy production would dramatically reduce the world's dependence on fossil fuels. But it'll take time, and lowering the costs of renewable energy might help us get there first.
The possibility of a future that is good for our children and our children's children with a good standard of living demands fusion. There's no other solution.
Standing here at the very centre of this reactor that could quite literally change the world is a really powerful reminder of just how impactful the construction industry can be. You know, none of this would be possible without the sector that so many of you work to create every day. Yeah, the spot where I'm currently standing in decades to come could be seen as the birthplace of a new kind of energy on this planet. I'm not sure it gets cooler than that. This video was made possible by Think Projects. You can learn more about that at the link below. And as always guys, if you want to get more from the definitive video channel for construction, from the channel that takes you inside the very heart of a nuclear reactor, make sure you're subscribed to the B1M. Ooh.